Well, good morning, good evening, good afternoon, wherever you're joining us from for Creation Research and Creation Conversations. Welcome back. We've got most of the team again tonight after our little hiatus last week. And I have to explain, last week I was at the Truth in Science Summer School, which is that's like the likes of Andy McIntosh's research group, and they hold a summer school every year. There's about 150 young people go, and the idea is to train them and to help them to basically take on the world of college and university and also just general life as well. So it doesn't cover just some of the science stuff, which I was dealing with along with Andy McIntosh and others, but it also deals with some of the more social issues of the day as well, and some of the challenges that Christians face both in the workplace as well in the research and medical labs. So it was a good program, but what had happened is in famous Truth in Science summer school style, we had started about 15 minutes late for the evening Q&A panel, which was supposed to go on for about half an hour, but went on for almost just over an hour in the end. And so by the time that I got back and started to set up stuff for Creation Conversations, it was just too late to go live. So apologies for last week, but we're going to be carrying on with what we were due to do last week, but do it this week, which is a mixture of reports as well as commentary, if you like, and conversation from the rest of the team. So if you remember, the last few, I think the last 2 or 3 programs that we've done, we've had Craig come on with his report of his travels around Australia, and it worked really well having somebody give a report and have the rest of us have a chat through and a talk through and talk about some of the science and the wheres and whys and wherefores about the background of the research. So we're going to effectively do the same again, but this time we're going to do it with Glenn's trip all the way through the USA. So we'll get onto that in a little bit. And this is a format that we're wanting to try and take on for Creation Conversations going forward. So do keep an eye out for updates about that. There'll be some polls and things coming out later as well in the week, talking about some of the new updates that we're going to want to be doing for Creation Conversations going forward. So do keep an eye out for that. Let me just kick things off with a little brief report from myself, and let me see if I can bring up a screen to share here, because this is actually the Truth in Science Summer School that we were at just the other day, or last week. Let me see if I can bring my window up. There we go. It's up here somewhere. In fact, let me do it this way around, which may be a bit different, but there we are. Oh, that's a share screen. Never mind. Let's try and do it this way. Okay. Oops. There. Hopefully that works. Can we see that?
Yep.
Full screen. Excellent. Well, this is the display that we had for the Truth in Science Summer School. You can see it's obviously, your classic creation research resource display, but you can see over on the right-hand side, we've got a few new display things. We do like to take along some museum exhibits and exhibitions as we travel around, and that includes to your churches as well. You'll remember from Craig's report that he took around some of the fossils from his museum as he went around in his road trip. So yes, we do like to try and take some displays and stuff, and this is actually a sort of a proper collaborative thing within creation research, because you see I managed to source a number of Lucy skeletons, the casts of the Lucy skeletons, 2 of which I sent on to Australia, one for John, one for Craig, and then John in Brisbane helped to develop a whole series of murals detailing information about Lucy, but also you can see the brain drain display there as well, talking about how we've gone from good to bad to worse. And we don't have as much space in Australia, generally speaking, and that is just as true for the museums as well. And so what I spent a little bit of time doing was taking these murals that were very, very well done by Australia. So shout out to Gary and Steve and some of the others who've been working on them, along with John and Diane, who helped to do the content. But what I've done is we've taken them and actually put them into roller banner format so that we can kind of utilize them at the museum, but also actually have them on a traveling exhibition. So yes, if you want Creation Research to come and visit your church or your school or your group, then get in touch, because this is the kind of thing that we're wanting to produce and copy around the world, so that we can come and bring you the real evidence. Then we went to Kevin Lee, which is a big homeschoolers conference in Wales. We've been going for about 4 years now, and the first 2 years we were going, we just took, a whole bunch of stuff, right, to go on display. Very good, very popular, and I'd do a whole load of activities as well. But a couple of years ago, the comment that was made was, can we try and do something a little different every year? And so what we have decided is to use this conference, this retreat, as a sort of a trial ground, a guinea pig ground, if you like, for some new exhibitions. So last year we developed our Living Fossils exhibition, which is now on display in the Creation Research Centre in Oswestry. And then this year we did the Big Question exhibition, or the Big Questions exhibition, which the three big questions was dinosaurs, ape men, and evolution. And again, these are all murals that have been put together, or many of these are murals that have been put together by our Australian office, which we were able to translate into roller banners: Science and the Bible, the Real Conflict. And in fact, John has said many times that if you want an amusing challenge, ask a university student, or suggest to a university student that they write their next thesis on the effects of Noah's flood in the real world, or the benefits of using Noah's flood geology on modern science. And you'll find that you won't get very far at all, because the real conflict between the Bible and science, you can actually see it there on the roller banner. The Science Teacher, November 2003, scientific theories are therefore explanations about aspects of nature without reference to God. Now, just about 200 years ago, you had Louis Pasteur, one of the greatest scientists ever to have lived, say that science was thinking God's thoughts after him. Now, I think that's one of the best descriptions of what science actually is, right? So how did we go from science is thinking God's thoughts after him to scientific theories have nothing to do with God? In fact, they have to exclusively exclude God. Well, you can see where the banners go on to talk about Darwin, and then talk about Charles Lyell, who was Charles Darwin's mentor, and then the fact that Charles Lyell's aim was to free science from Moses. You see the conclusion there? The real battle is not religion versus science, it's truth versus error. You see, these murals are designed to make people think. But we've said that before, right? We have a museum project. Museums are designed to make you think. It's written there in the name, right? Muse, think about, mull over, get your brain working. The reality is most museums now are no longer museums. They are simply there for your amusement, non-thinking. They just present a whole load of nonsense and a few nice dinosaur models to make you happy or amused. So yes, with the Creation Research Museums, we really do try and get you to think through things. Oh, there's the full Lucy display. Doesn't it look good with Lucy in the middle? Well, you see everything about Lucy, from the jawbone to the size of the brain to the proportion of the arms to the hip. It all shouts the fact that she was an ape. She wasn't a human being, and not even a human ancestor. In fact, don't be scared of challenging people, and don't be scared of understanding what names mean, because as Dino has pointed out many times, Australopithecus simply means southern ape. Oh, that's Lucy's proper name, if you like. But in fact, we had at the Truth in Science Summer School this display, and we spoke to Nigel Jones, who I'm hoping to have on the Creation Conversations program one day. He's a retired medical surgeon, and he's a big supporter of the work that we do and the work that John does. But you see, I showed him this skeleton, and I said, can you tell me what kind of skeleton we're looking at? Is it a human or an ape? And he took one look at the vertebrae and he said, well, you might be able to get a human spinal cord through that bottom one, but there's no way you'd get it through anything else. And even the body proportion tells you that it's an ape. You see, the medical professionals certainly know what they're talking about. There's Lucy there, backlit. And this is a mural which I sort of put half together anyway. You see our giant boa constrictor skeleton there? It's a real one, by the way. We have it in our museum project. And you see the little tiny snake as well? Well, you see, you might even say that it's good to bad to worse, because, yes, you get a huge amount of diversity in the world today. But have a look at the mural. You see the size of the boa constrictor, only 10 feet long. I mean, even the biggest ones can get to around 14 feet, but 10 feet is about your average. But it's absolutely nothing compared to the titanoboa, which could have reached up to 50 feet in length. Now, that's pretty enormous. That's pretty impressive. Yeah, snakes identical in every way between the titanoboa and the boa constrictor, except that one is big, one is little, simple to complex, good to bad to worse, devolution. That's the point we make at the top there, right? And the little mural at the bottom, you can actually see the original fossil of this from J. Taylor in the Brisbane Creation Museum. Your modern salamanders tend to be tiny little things. The largest that are alive today is the Chinese or the Japanese giant salamander. Still not too big, but especially rather when you compare it with the giant fossil one, the Metoposaur. So yes, the real history of the world is good to bad to worse, and we use this example everywhere. Oh, and this is one that I think you might be interested in, Glenn. I know that John is. You see how we've pulled together a whole bunch of these polystrate tree murals. Well, I put together the banner over on the far left-hand side, right? Poly meaning many, straight referring to strata or layers. So polystrate passes up through many layers. Many of these trees, by the way, are ones that have been uncovered by creation research exclusively. One or two of them, like the ones that were published in the National Geographic and in the Old Geologist's Journal, the one in Manchester, right? But you see the point that we make in the mural? Polystrate trees have no branches. They have no roots. They have no soil at the base. There's no leaves in the coal. They're buried next to giant marine shells, buried in water deposited strata, and they're found worldwide. And in fact, you can even do experiments with test tanks and sticks to show that these trees have been waterlogged. They've been washed along in water. So everything from the polystrate tree off of a highway in Tennessee to the polystrate tree that you have to use quad bikes and side-by-sides to reach because it's in the middle of nowhere, to the one that I think you visited recently, Craig, in New South Wales, all the way through ones in the UK, you see these polystrate trees are found all around the world. Great display to actually show people that this is evidence of a worldwide flood for sure. Creation, yeah, is it a new idea? You'll find many critics claim that it was the Seventh-day Adventists that dreamt up the idea of young earth creation. It's complete nonsense. You see that Bishop Theophilus, all the way back in the first century, claimed that creation occurred just a few thousand years ago, not the tens of thousands of Plato, etc., have written. And you can read about many of the church fathers and the reformers and their beliefs on creation. And, well, you can't see the full slide at the full panel at the bottom there, but it says, therefore, it's not the evidence that disagrees with the biblical record of creation and Noah's flood over the last 6,000 to 7,000 years, but it's the opinions of mankind that set out to discredit the word of God, just like it says in the book of 2 Peter. Yeah, murals have always been good for teaching people about creation. We've got creation to the fall, the global flood to the Tower of Babel. It's a great way of getting people to realize the real history of the world in picture form as described in the book of Genesis. Dinosaur history, we had a huge dinosaur display, and we'll talk a little bit later about that mural over there on the left-hand side about the presence of original biomolecules or soft tissue in ancient bone. There's been a new report that's come out just a couple of days ago that's well worth talking about, which we'll come to later after Glenn's little program. It was a great time to be able to engage with people, to be able to talk to people, to be able to display this stuff. And by the way, just a little bit of fun here. Here's one of our regular volunteers, Joshua, who at the homeschool conference, they put on a concert at the end, right, where they put the talents of lots of young people on display, from recitals to playing instruments and piano. And, well, I don't think I've seen anything quite as cool as a Spinosaurus with a rock guitar before. But you'll find that they put on an absolutely epic show. These are the same family that come and help us to do things at the museum, as well as our big dinosaur convoy that we had down in the Osler Street Christmas Parade, which, by the way, we're going to be doing again this year. But let me just give you a very brief little snippet of some of what they were doing, because I don't think you've seen anything quite as cool as a rock and roll dinosaur before. There you go, a little bit of fun of a rock and roll dinosaur, but we'll finish that there and come back to the others. I think that was great. And I'll stop sharing my screen like that. There we go. And come back to the others as we carry on down through some of the program for tonight. So I think, first of all, Glenn, it's over to you to introduce how we do or what you've been doing over the last little while. And then we'll go through and chat about some of your finds.
Well, it's good to be back. I've been out for a while, but I've been chasing things like this. This is a fish fossil with plant material around it. You're going to see some things like this. It's hard to recognize, but that's actually a stingray. We're going to talk about that. And if we have time, we're going to talk about this, because that's part of where I've been and what I've been doing. So let me share my screen and we'll get started. Should be that one. All right. So where I went out in the western part of USA, out to Wyoming, and was digging fossils in this Green River Formation. It's quite large. It covers 3 states, 65,000 square kilometers, and it's fairly significant formation. Ruby and I had been there 8 years ago and dug fish fossils and just couldn't wait to go back. So let me tell you a little bit about the Green River Formation. This was written by a Dr. H.M. King. And they consider it a fossil lake, as you'll see, that they say was formed over a 5 million year period. This is a quote from him. He says, "The Green River Formation contains a story of what the environment was like about 50 million years ago. Streams draining the steep mountains carried large amounts of sand, silt, mud, and dissolved minerals into lakes that occupied the Intermountain Basin. Over time, the sand, silt, and mud began filling the lakes, and the dissolved minerals altered the chemistry of the lake waters." And the question is that story, because it is a story, is that story true and supported by what we see? Well, in this Green River Formation, you find all kinds of things. You find birds, you find plants, alligators, lots of plants and lots of fish. It's what it's most known for. And some of these are, either in the act of eating or have just been squashed and vomited out what they just ate. So we started out there, a 3-day trip in our RV, and this is how our trip started. 3 days in a row, 3 days in a row of in mechanic shops and being towed. There's nothing like driving down our interstates at 70 miles an hour in an RV when all power is lost and you don't even have blinkers or emergency lights, and all you can do is coast off the interstate. But we never gave up. We had 2 other ladies from our church that joined us, and look, we had prayed about this trip and prayed about it, and we were just convinced God wanted us to do it. So we weren't going to let breakdowns 3 days in a row, 4 different mechanics, stop us. Instead, we loaded up everything that we had into a little trailer, U-Haul trailer, and kept going. Left the RV with the mechanic, thinking may be there forever. But we got out to Wyoming and made it to the quarry. And this is the sign as it welcomes you to this quarry. It says, "Prepare to descend 52 million years into the past." Here's the quarry. Now, Ruby and I had been here, like I said, 8 years ago, and this is the same quarry. The difference is now they don't let you go pick the blocks off the side of the quarry yourselves. Instead, they have a big excavator that picks up the blocks, lines them out in lines, and each day they let you split one of these lines. And that was a lot of fun before, but this time we had two ladies with us that they've never dug fossils before in their lives. So I wasn't real sure about how they would do, but they started us off. They started us off with a little talk about how this all formed. Basically the same story that we read about before. Now, keep in mind, this is a 600-meter thick deposit, and it's a couple of 100 yards wide, lengthwise, of this rock wall, and it's probably moved back a good 20 feet in 8 years, not very far. So it's called the split fish. Some geologists call it the sandwich layer, and it's because it's got these fine layers, these very thin layers in the limestone that let you split it. We're going to look at how that's done. You can start off by splitting off a big block like this, or you get it down to finer and finer layers. And we're going to show you how that works. Joe, you want to play this video?
Sure thing. Let me just pull it up here.
This is my wife on the left, and that's Angie Robbins with us.
Here we go. So I just to let you know, Glenn, your mic will be muted when I play.
Let me get my chisel in here.
Oh, yes.
Watch ankles.
Watch your ankle.
End of the hammers. Twist it.
I got a good picture of the
Oh, you got a little tiny fish.
Not much.
No.
And shall we play this other one as well? Yeah.
Well, the other one of me splitting some material that we brought back with us. By the way, before you do, you can look in the background. You see the big plant, the big stick that we've got from there, from the trip. Go ahead and play it. So we just made that big split. We didn't find anything. So I thought I'd make another little split, and I split this one, and we have a nice fish.
Ah, good.
Almost a complete fish. So you never know. You just got to keep splitting and looking. You can stop. Joe, let me know when you're back to me. Don't play the next slide yet.
We're back to you, yeah.
Okay. So these are just some of the pictures of the various fish that we find. Now, these are mostly, well, we'll talk about this. They're identical to sardines and herrings that we have today, but they consider them to be extinct freshwater fish. But like I said, anatomically, they're identical to what we have today. We found lots of them. We found over 100 of these. But the very first thing found was the one I held up a while ago, which was the stingray by one of the ladies who's never dug fossils before, never split for rocks for fish. And the very first thing she finds, and the young guy who's working there is the guides. One of them said that I think it took him 3 years to find his first stingray. And so this was amazing. So she spent the next hour looking for the rest of this stingray, but didn't find it. Then at the end, we had it for a 4-hour period. Then you're allowed to go and cut the rocks up. But we took everything back with us that we could haul back so we could prep them. Here's, you can see on the left, just a picture of what we brought back with us. Lots and lots of fish. And we brought back some big plates that had lots of fish on them, which is going to make for some nice displays. But once you get them back, you have to prep them. And Joe, you can play this slide now and you can see.
Yep, just coming. Here we go.
Trying to take off this very paper thin layer without taking the fossilized material off of it. And this layer is supposedly laid down over 1 year. That's 1 year's worth of deposition. Remember, it was 0.2 of a millimeter thick per year of deposition. Now, does that make sense? That this fish would lay there and not decompose that slow rate of deposition. And yet I can take that layer off and see the very intricacies of the fish. All right, so you're back to me.
Back to you now.
All right. So here I'm showing you here is a picture on the right. That's from the National Monument, which is just pretty much right behind the quarry, and just a display of all the different types of fish that they find. And we found many of those. We didn't find any quite as nice as those big ones. But this formation, it's known for having some of the highest concentrations of fish of anywhere in the world. And what's interesting about them is that they are so exceptionally well preserved that they not only have soft tissue, but you can tell even what the contents are, and for many of them as to what they ate. So let's talk about this story. Like I said, the most common fish are the Nidia and the Diplomitis, and those are the same as the modern day herring and sardines. And like I said, the first find that we made was a stingray, which is almost exclusively saltwater, and it's buried with land plants. I showed you the large land plant. We found a lot of other plants, some fish with land plants right there in the same fossil. And then you've got the fact that this 600-meter thick deposit is supposed to have been laid down by the erosion of the surrounding mountains. Well, having looked at lakes and even nuclear bomb craters and been able to characterize their different deposition events because of the layering, I can tell you this deposit does not fit that explanation, because all these layers, it's 600 meters thick, and yet that's over a 5 million year period. That comes out to right at 1/10 of a millimeter per year. Wikipedia will say it's just a little bit below 2/10 of a millimeter per year. Well, even at that rate, that's 5 years to get 1 millimeter of deposition. But if it's
If I just jump in quickly there, Glenn, just to reiterate the fact that this is the first point that Professor Derek Ager pointed out in his book on the nature of the stratigraphic record, which is basically saying that when you take your thickness of deposit and you effectively divide it by the time that it supposedly took to lay down, right? So 600 meters in 5 million years, you can do this all over the world. John first did it with me for Stanton, which is 20 meters, which is, 65-ish feet, over 10 million years. You end up with, 0.002 millimeters per year. And the point that Derek Ager made was that when you try and calculate the rates of sedimentation, the results are usually ludicrous. Right now, that's a quote from him himself, right? So you really are dealing with something that has to be different from your standard story of this is a slow, gradual deposit at a base. With chalk cliffs, it's supposed to be, bottom of the sea, calcareous ooze. This is supposed to be bottom of a lake, slowly building up. Your, Jurassic Solnhofen is supposed to be a shallow sea that slowly builds up over vast periods of time. And if you really take that assumption, and the beauty of what Professor Derek Ager was doing is that you don't have to deal with radiometric dates, you don't have to deal with carbon dating, you don't have to deal with any of these sort of, more technical things. You're simply doing a very simple mathematical equation, and you're putting two pieces of data into a simple division equation, and the two pieces of data that you're putting in, one is absolute, you can go and physically see and measure thickness of deposits. The other one is the arbitrary measurement, if you like. It's the dates, and you get ludicrous results every single time. And you were the one who first really took me through with that, John. So and you can apply this to all sorts, including like the polystrate trees as well.
I'll throw something in there too, Joe. Glenn mentioned the fact that these are herrings, and if you come to Australia, you'll still see them living. We have our Murray River freshwater herring, and you say, hey, this is a fish that I find in the Green River beds. So no matter how old you put on the Green River Formation, you have living fossils. The bugbear of all evolutionists, and it's time they admitted it. And so we used to say, stuff it in your pipe and smoke it. It's the end of your argument. So when you look at that, the Green River Formation is excellent example of rapidly deposited, not slowly deposited, but buried living fossils. Thanks, Glenn. Back to you.
Well, y'all jumped ahead because I was going to get to that very thing. Right here, I was just going to make the point that if this was a lake and it was being filled by erosion from the mountains around it, what would you see? Well, there you would have a closed system. You would get these alternating layers of very coarse gravel, then to the coarse sands, then to the fine sands, then to the silts, to the clays, and then you would get another deposition event. But in SID, just what you see here, each of these little layers, they're indistinguishable from a textural standpoint and a chemistry standpoint. So they give evidence of deposition by laterally flowing water. And this is in limestone, so laterally flowing saltwater deposits. And like I said, having characterized deposition events in a closed lake systems, I can tell you this formation does not represent that. It represents this laterally flowing sediment deposition. And then I was just going to quote from some secular scientists that says preservation's best when certain conditions are met. Yes, there are. And it has to be shortly after the organisms died. For the one thing, the organic remains should be covered quickly, yes, by sediment to remove the threat of post-mortem predation. Oxygen accelerates the microbial activity, and it can distort and damage the remains. Remember, these are very well meticulously preserved, so they haven't had the microbial activity taking place. And then others say, you know, it's got to be in anoxic conditions. That's a lack of oxygen. It's got to be rapid burial of these live organisms. And yet here's these layers, and you can see how thin they are. You know, that's like a paper. And that's what I was having to take off of these. And as Joe talked about, here's the mathematics. So for just these small fish, if you figure that they're 25 millimeters thick, well, that's 208 years that it has to lay there without any microbial activity. And that's just to cover it. Then you've got to bury it deep enough to squash it flat and for it to be anoxic and not decompose. So you're talking about hundreds of years. And then you've got alligators, which you've got to be talking about thousands of years just to get the first layer to cover it. And as he said, that just makes no sense. And then when you see all of these, you know it's got to be a massive mass mortality event. It's got to be a rapid dying event. Well, what does that sound like? So this is what we observe. And my question is, what could cause these mass mortality events that occur all over the world? Joe mentioned the one in Germany that's just identical to this. And it's a mass mortality all over the world of creatures that include salt and fresh water, plus land and animals and land plants, buried so rapidly that they're not scavenged and not decomposed, buried deep enough in oxygen-depleted sediment to squash them flat and then turn to limestone. So what would cause such an event? Joe, I'm going to stop sharing at that point, and we can go back and we'll see if we have time for the other part of my talk. Let's see if we
Joe, when I had you out here in Australia, we visited a fish farmer who really opened our eyes to how quickly fishes that fall to the bottom, because some of them will do that rather than just float, what happens to them in their experience, how long can they actually last? And Glenn, I'll ask you in advance just one question. Did you find many bits of fossil poo with the fish?
Oh, all over the place. I'm looking to see if these had it. We had several with the fossil poo. Yes.
Good.
And we kept
Okay.
some that have the fish with the poo as well.
Yeah, very, very unconstipated fish. Joe, fill us in on what we learned that visit to the fish breeder.
Yeah. So you've got the standard argument, which is that these fish have lived and died and sunk to the bottom of the sea or the lake or whatever, and have slowly been buried, right? We've got the graphic from the Natural History Museum in the UK, as well as the Colchester Natural History Museum, which basically has these fish dying and sinking to the bottom. And that becomes a problem when you realize that the majority of fish don't sink to the bottom. They'll bloat and they'll float. If you've watched Crocodile Dundee, you know, he set a bomb off under the water and they all floated to the top, right? But you also find that there are certain conditions in which these fish do sink to the bottom, whether if they don't have, if they don't have swim bladders like some sharks, or if they're in very cold water conditions where they sink to the bottom, right? Which doesn't match what the Green River Formation is, by the way. It certainly seems tropical there. But anyway, even if you do have fish sink to the bottom, you still have a problem because you still have bacteria and fungus that lives on the bottom, specifically good at decomposing tough things, right? Like silica-based seaweed or fish keratin scales. And you'll find that they'll catch hold of the fish. Some of them will even anchor the fish to the bottom of the seabed, so they've got no chance of floating up, but they'll actually, within just a few hours, begin to decay and decompose and destroy the fish at the bottom of the tanks or the bottom of the sea or river or lake bed or whatever. So you still have a problem of decomposition. Even if you have fish that sink to the bottom, you've still got to get them buried deep enough to be able to not only preserve them, stop them rotting away, but they have to be deep enough to stop things from burrowing down to them, to stop things from burrowing up to them, to stop water from washing them away. And you've still got a problem with funguses and bacteria actually decomposing and destroying them. So you're clearly dealing with something which is far, far more rapid and far more catastrophic than your standard fall to the bottom of the sea and slowly be built up. Right? Especially when you then find things with, buried next to plants and so on and so on and so forth. In fact, I think it was on the Blue Planet, the BBC David Attenborough documentary, where they found whale death, which is basically an enormous whale, right, that has died, and eventually, normally when whales die, they bloat and float, and then eventually they explode. You can read the old sailors' records of the exploding whales, right? But once they have exploded and they become waterlogged, they sink down and they reach the bottom of the sea. And they found one of these, and you just saw that it was absolutely teeming with life. Right, everything from hagfish to crabs to lobsters on there, eating it away. And they visited it, I think it was 6 months or a year later, but they visited a fairly short period of time later, and there was nothing left but a few scraps of bones, which would very soon disappear. So nothing left within, I believe it was less than a year, if my memory serves me correct, to actually destroy an entire whale. Now, think how much less time it takes to destroy a small fish. So you're definitely dealing with something which is far more rapid and far more deeper than what we would observe under normal circumstances. But John, this is really the result of Lyellian thinking in terms of present being the key to the past, because Lyell was not just pro-uniformitarianism, he was also anti-catastrophist in all forms of the sense.
Yeah, he certainly was. In fact, being a lawyer, he was far better with words and grammar than most people give him credit for. He knew what he was out to achieve. And number one, he was out to destroy confidence in Noah's flood and catastrophic geology. Now, he did it by just absolutely annihilating in people's minds any sort of catastrophe at all. So that we now get to a world where, when I did geology, the professor began by saying, we are not going to discuss any such catastrophic rubbish. Now, I didn't come from a church family background, so I wondered, what on earth is this all about? And then I discovered the real aim was aimed at Noah's flood being catastrophic. But what you did was demolish any catastrophism, so that when I started geology, they didn't even have local catastrophes on their schedule. Now, they backtracked a bit from that because it's so obvious that many things like Mount St. Helens and that form rapid beds, they deposit quickly, they are catastrophic. So they've been pushed back a little bit. Praise God for that. But be careful you don't fall into Lyell's other trap. He wants you to demolish all catastrophism. In his aim is to get you to think, well, if all catastrophe is out, then Noah's flood is out. But in reality, there'll be big catastrophes, there'll be little catastrophes. So use great wisdom. Now, Joe, just to ask you a question, I'm sure you've kept fish, and I noticed that Anne has kept fish there too. I have kept fish in tanks. We've done this for years. And the one thing I noticed about their poo, and sorry to bring back to poo, Glenn, but you find plenty of it. I've got heaps of specimens from yeah, great stuff. Look at it. Look at it. It's all over the place. And the reality, when you keep an aquarium, it's almost as if this is a living food supply for the fish that's waiting there behind the other fish just to swallow up the poo, almost like, rotating probiotics. That's what it is. And when you live in the real world and you go scuba diving, whatever, I'm sure, Glenn, you've done a lot of scuba diving. The one thing you don't find is piles of fish poo on the floor, correct?
Well, I was scuba diving yesterday in a freshwater lake, and that was one of the things I was really looking for. I got all excited because I thought I found it, and I picked it up, and it was decomposing rubber worm. So,
okay. Now, since you mentioned what it was decomposing, the other thing that I notice about deposits like the Green River is the absolute anomalies that are there. You have herrings with palm trees. You have herrings with all sorts of sticks. In fact, if you actually do what you're supposed to do and add up the life that's there, the biotics, add up the plant material that's there, it is an absolute anomaly. The plants and the fishes do not match one another, right? Whether you're thinking of a desert environment like the middle of Australia with the Murray River, or whether you're thinking of a tropical environment, the absolute match is just not there. So this is not a buried environment. Joe, you'd agree with that necessity of that analysis?
Yeah, very much so. And you can see this in, the examples that Glenn has got, some of the examples in our museums around the world. I mean, you've got some spectacular fossils, John, in from the Green River Formation, vomiting fish and all sorts. We've got one of these regurgitating fish, which we're pretty sure is regurgitating rather than being swallowed, because you can even see all of the mouth marks right down the back of the fish where it's been squashed and forced out. And that's the other thing. These fishes are squashed. Right, they're flattened. They're still 3D because they've still got all the individual 3D bones in them, but they're squashed, they're flattened, and have had a huge amount of force that has forced this stuff out of their mouths.
yes.
Yeah. So therefore, when you look at these catastrophic deposits, be careful. Mega catastrophics, minor catastrophics. Don't fall for Lyell's trap of saying all catastrophism's out, or don't fall for the other one of making fun of you because you said something is a major worldwide catastrophe when you can actually map the edge of it. Now, Joe, you and I have done a lot of work on Jurassic and Cretaceous and all of that. And you remember the green layer that's underneath some of those that goes all over the globe?
Yeah, so you can find, when it comes to Cretaceous, so remember Cretaceous means chalk. It's the Latin chalk rock, right? Now, where can you trace the Cretaceous deposits? Particularly, let's go specific, right? Where can you trace the chalk deposits? Well, as John just mentioned, you have the greenstone or the green sand formation, which comes in two forms, which is your green sand or your karstone, right? It's basically the same layer of sandstone. Now, bear in mind as a side point, when you're dealing with sandstone, you're dealing with a size of grain, which means you need 3 times the amount of original material to erode away in order just to produce your sand, right? So you need a huge amount of water deposit, or water erosion rather, not just to get, deposit your sand, but get your sand in the first place. Okay, so where do we trace the chalk? Well, again, John has traced this, I've traced this, but we can also go to Professor De Gager, who traced it as well, right? Because he said the chalk extends in essentially the same form from the Texas, Austin chalk in Texas, all the way across to the Donetsk coal region, right? Well, Donetsk has been in the news a lot. It's in modern-day Ukraine, right? In formerly USSR at the time that Deregaja did the work. So you've got something which not only is provably same deposit of rock, because it all sits on the same bed of sandstone, but you've actually got something which doesn't cover a few states. It covers a huge volume of continental, boundaries as well. It goes across continents. Now, what's even more amazing is that Professor Deregaja thought that he'd mapped out all the chalk right from going from Texas to the Donetsk coal basin, but it turns out that it's turned up in even other further places, including over on the west coast of Australia. So you find that this is now all of a sudden a global deposit on an enormous scale, right? And if you think 600 feet is thick, you'll find that some of the thickest chalk deposits in the world are over 1,000 feet thick, right? In places like Norfolk, where you can go right the way down, you're talking mind-bogglingly enormous scale. And the other one that's worth pointing out, John, because you can do this as well with the Jurassic and the Ordovician and so on and so forth. But the other one that Professor Deregaja pointed out was about the Carboniferous, Pennsylvanian/Mississippian, if you're in the States, which you can not only trace across the entirety of continental North America, right, but you can also find it in the same form throughout the rest of the world, Europe, Asia, down on the west coast of Australia, and in fact it's some sort of, I think it is 170 degrees of latitude. That was the quote that Professor Deregaja used. It's certainly much more than that. So now that we found it in Australia, so you're dealing with something which is on a far greater scale than even countrywide or continent-wide. You're dealing with something that is intercontinental.
Just one more question, Dan. You dug up heaps of fossils, brought them home. Well done. Museum in the USA will be progressively going on. But having had a look at some of the ones you've been working on, did you notice whether you had any fish that were polystrate to the strata, or were they all flattened? Flattened into the strata?
They're all flattened into the strata that we found, but there are some that are different thicknesses. Certainly, one very large one, very thick.
But the one thing I'll guarantee you didn't find is a fish standing at right angles to the strata.
That's exactly right.
Right, so they're all pushed over. So one of the evidences that this has been a current washing in, bringing anomalous plants like palm trees and fruit and sticks, as well as the fishes, everything has come in sideways. And then as it's been deposited, everything has been squashed, whether it's the fish, whether it's the branches or whatever. So it's definitely a regional catastrophe on an impressive scale, but it's not a community that's been buried. Did you catch what I just said? And Joe, you might want to comment on that, where you've been not a community that's been buried. It's from a wide area that's washed in and suddenly buried in massive laminations. I regret, Glenn, because I sent you an email saying, make sure you get to the 18-inch layer, and you didn't. What happened?
So one of the interesting things about our trip is we pressed on through all the adversity. And let me tell you, just like on this event, every event, we would go do what we had scheduled to do. We had that place reserved from 8 till 12. At 12 o'clock, we finished, and it started raining. And by 12:30, it was lightning. And we got back to our hotel room. It was hailing. So obviously, God didn't want me to do the one that was going to be the 18-inch layer, because we went, met up with him, and sat in his shop talking for 2 hours while we watched lightning striking all around us and hail coming down. And he said, I don't think we're going to be able to do this. He said, come back tomorrow night. So we went on to Yellowstone, spent the day at Yellowstone, came back that night. Same thing. So obviously God didn't want us to do that, because every event that we did, even going to Yellowstone, we did the entire thing at Yellowstone. As soon as we got back out, man, down comes the rain and lightning. And you know what happens out west when you get at least little rain, you've got flash floods.
Well, we're glad you made it back safely and used your common sense there.
Yes. So we didn't get to the 18-inch, but I learned a lot in talking with the person that preps fossils for museums and runs that other quarry for the 18-inch layer. Well, was going to add, John, you brought up a good point because I've been in the Atchafalaya Basin at a massive fish kill. It was after a hurricane, and I went in with my father-in-law to retrieve his hoop nets. And the wildlife and fisheries people of the state of Louisiana said it was a complete fish kill, that it was a total kill. And it was because of all the organic matter that was pushed down and all the trees and leaves in the water decomposing just removed all the dissolved oxygen from the water to where it was a massive fish kill. Well, what did the fish do? They bloated, they floated, they formed debris piles, and they were just piled up in every kind of configuration. And that's not what we would see here. We did find a tremendous amount of fish, and you saw the plate where there were 6 of them, but in a bloating debris pile, they would be all over the place in every configuration. So you got to have a mass mortality event that quickly buries them, and it's clearly in a flowing water type scenario.
Yeah. Very good.
Yeah, well, I'd just like to add something as someone who's bred tens of thousands of fish. So we've bred up to 100,000 fish a year, and I've seen a lot of fish death, I can tell you. But I just throw a curly one in there. They don't rarely in a fish farm. The initial thing they do is actually sink to the bottom when they die. So you generally find them dead on the bottom, but because we're in a farm, we've got to get rid of them quickly. So we take them out generally as soon as we find them, which would be less than a day. But the bulk of fish, when they die and fall and go to the bottom. It's probably something later that happens with the bloating. Maybe if it happens straight away, it's because of what they're eating or whatever is going on inside their guts might cause them to float. But I mean, we've all seen the pictures of mass fish deaths out in the ocean and so on, where they're all floating and being washed up on the beach. But it's not always the case that's what happens straight away. They can actually sink. And so you could have a death by some sort of chemical imbalance in the water, for example, that they die, they go to the bottom. And then if you've got a big layer of sediment come over, they'll come straight over the top. So I don't think we should.
Yeah, that's the key. It's got to be very quickly. Yeah.
It's not always just a single process is what I'm getting at.
Yeah.
Yeah, that's why that fish farmer's observation that he either had to rescue his dead fish to save the other ones, or he noticed a fungus would come and do it for him. So there are ways of cleaning these up, but you can always tell a bundle of fish that's just been covered up because you'll get polystrate fish in it, not just flattened fish. So you see this in some of the Scottish deposits. Have you seen the Scottish lungfish beds, Joe?
Oh yeah. No, I've gone up and dug there, and you find that you've also got it where it's been trapped so quickly that you've got almost like an iridescence, like an oily iridescence on it, which is effectively biochemicals. It's soft tissue, it's living matter that's trapped in there, or fresh soft squidgy stuff that's trapped in there. So you're definitely dealing with a very, very fast and rapid deposit of these fish. It's the old sandstone deposits up there, isn't it? The old red sandstone deposits.
Yes. I've got some lovely lungfish fossils from up there, and even further north in that beautiful fish bed halfway up Scotland that's sort of semi-off limits now to many people. But I noticed we've got someone in the chat asking about why do you have a Christmas tree, Craig? Would you like to tell us?
Yes. Well, it'd be a strange Christmas tree. This is actually a living fossil. It's a Wollemi pine, so it's the southern pine that we often talk about. Dinosaur age according to the secular time scales, and it's found in the 1990s, living in the Wollemi National Park, northwest of Sydney, and I've bought a sample of it to grow on my property just out of town here.
Okay, now we've tried growing some of these in Queensland, Craig, and we have a little fungus that ruins all of our enterprises. How come you're not going to have that problem down in Tasmania?
We don't have it as widespread a problem, but also you might have got some of the earlier samples of them that came from a nursery that had the problem built into it. Whereas
That's
this,
exactly what happened. We wasted our money, so we're trying again with some grown clone plants from up here. That's good. But you did mention it was found in the Wollomai National Park. I have to let you in a little secret. The actual property is now the Wollomai National Park, but where they were first found, it wasn't. I know that because we know the bloke who owned it. So it's very interesting what the government paid for and has kept really hush-hush in terms of its original find over there. So never necessarily believe what you read in official government reports. Always find out as much as you can. Diane, before we go any further, we haven't heard anything from you. You're sitting there quite cute this morning, but you have released a newsletter in the last few days. Would you like to tell us some things people can catch up on?
Yes, we did send out a newsletter yesterday. So depending on your time zone, you would have got that. But yes, we've got a few interesting things on that, including some things that scientists claimed were unique. One of them was a unique protein that's produced by a bacterium that rejoices in the name of Dinococcus radiodurans. Perhaps next week we can do a few more details about this when we've got some more time. Another one was an interesting study about human hearts and ape hearts. If any of you have ever had an ultrasound scan of your heart, it's a very, very useful diagnostic tool for looking at heart function and heart structure, because you've got it there live as it's happening, and you can look at the structure and the function together. A few enterprising people worked with some vets and people at wildlife parks and did this on some apes and compared it with human hearts, because in order for an ape to evolve into a human being, it takes more than just bones. We showed you some bones with Lucy there, and that's what people concentrate on, but you've got to think of the whole body. And they found an interesting difference between the human heart and these various ape hearts that relates to how human beings stand upright, but also to do with our brains and our activities. So you can read about that. And then we always like to try and put in a few interesting little quirky design things, because the world is full of wonderful things that we can praise the Lord for, clever design. And we found one about head banging bees. Now, we had some rock and roll dinosaurs there, real sort of disco stuff that tends to sometimes make young teenagers indulge in various strange body movements. Well, this is about head banging bees, and they're head banging inside flowers. So you can read about that. So maybe next week we can give you some more details on that. But do have a look at those if you get our newsletter. If you don't, sign up for it. It's free. Just go to our main website and go to the newsletter page there, and you'll get an email version of it every few weeks. Otherwise, after it goes out, we do archive all these items separately, so that on a separate website called the Fact File, and you can just look up the individual items. You don't need to know when they were sent out, so you can just do a keyword search. So have a look at that. And there are a couple of new questions on the Ask John Mackay site, our question and answer site as well. One is about Darwin and his attitude to Aborigines. And in fact, that's quite relevant to our new display in the new Brisbane Museum. So if we can go back to us, John, you might like to talk about that.
Sure. And I will take a launch off there, Diane. For those of you out there, and Craig has been reminding us all week, we do need you to share our newsletters with those around and to increase the number of people who actually receive it. Yes, we love to share all the stuff with you. And yes, we do Appreciate all of those folks who send in gifts as you're doing on the chat there at the moment. But we need that on a bigger scale. So increase our mailing list, get your friends to subscribe. It's free, which you can all afford. And we need your support out there in America, in England, in Australia, etc. So please do that. But I'll mention one thing, and Craig has a little notice he'd like about his museum as well. Yes, we have a great new display on Australian Aboriginals coming up, which is what people are asking about, Darwin and Aborigines. And it's just a fabulous new display coming up at the end of September, the last Saturday and Sunday of September. It's free, but if you go to our creationresearch.net, you will notice we have a electronic application form. You must enter your name here and the number of people who are coming, because our biggest room is a 50-seat lecture room, right? So that's the maximum people we can have on any one day. So we've got several days of open days, 28th and 29th of September. Sign up now and get yourself in early, because it's absolutely shaping up to be a fabulous new display. Diane, you'll be up there?
Yes, I will. I'm looking forward to meeting people.
In fact, I know you're looking forward to meeting people. We really need you up here to erect Lucy, don't we? Because we've got a Lucy display coming up too, and I have no intention of putting all those bones together. Craig, you need help in your museum, and when we've finished your little herb, I'm going to ask Joe a specific question about his research. So, Craig, what do you want people to do?
Oh, well, we've moved to 6 days a week open now that we've got to September, coming into the tourism season. And we've lost a few volunteers. Sadly, while I was away, one of our volunteers actually died, which was very sad. And we've got others that have dropped out, age and so on. But if you're a retiree or someone that's got a bit of time available during the day, you don't have to have any particular creation experience. Just got to be someone that loves Jesus and would like to man the counter and help us there. If you're in Tassie, come along.
Great stuff. Joe, before you give some thank yous, do the thank yous before you do the article. I sent you a very important article that deals with your research sort of side at the university. So give our thank yous and then tell people, before we throw it open to everyone's questions, as to what this new research on, what was it, cholesterol in dinosaurs or something?
No, you mentioned cholesterol earlier. This isn't a new theory about how they died out. Let me share a couple of thank yous, and then we'll talk about collagen in dinosaur bones. We've got two thank yous at the moment. We've got a thank you from George Bond. So thank you very much. We appreciate your support. And we've got a thank you from Neil Grindley as well. And yes, apologize that the YouTube channel is a little bit last minute going out. We've got a few plans for YouTube as well. It seems like a number of people have been missing our sort of scheduled stuff over the last couple of weeks. I know we've been a bit on and off, but we've got a few different plans for upgrading creation conversations and the stuff that we're doing on our YouTube site. So we'll plan to do that and get that sorted in the next little while. So do bear with us while we go through with that. I've got a couple of things to sort of show you and to talk about. To start off with, let me pull up this report, which Diane actually found. It's quite new. And this, by the way, is one of the things that always impressed me with creation research before I was involved in it. And of course, now I'm part of the team that does this. I remember back in 2014 when John was sharing at the Answers Mega Conference that I'll be sharing at later on this year. He reported on a paper that had been published in Nature, the famous journal, and had been published that morning. And of course, later I found out that it was Diane who'd found it and forwarded it to John. So good on you, Diane. But it really does just sort of go to show how up to date so much of creation research has to be. This is a paper. Well, it's not really a paper. This is a report on a paper. As you can see, it's a story in Science News on a paper. But you can see a chemist explain why dinosaur collagen may have survived for millions of years. Notice the may have there is quite an imperative part of it. What are we talking about? Well, for a long while, we've known that collagen, which is a principal component of bones, is a very fibrous protein. It is a protein, however, it is original biomolecule. It is soft tissue, okay? It is protein, like meat is protein. It's not an inorganic mineral like calcium in your bone, so it is an organic part of your bone, okay? Collagen has been found in dinosaur bones as old as 195 million years. Well, even though this was published just, 2 days ago on the 4th of September, it is it's not out of date because we haven't actually published on it yet, but we've actually found in some of our research collagen in stuff that is over 200 million years old. So this is quite remarkable stuff, this collagen that's found. But notice what they say here: this far exceeds the normal half-life of the peptide bonds, which holds protein together, which is about 500 years. In other words, after 500 years, half of your peptide bonds should have broken down. After 1,000 years, another half of them have broken down. Under another 500 years, another half of them have broken down, and so on and so forth, right? So in other words, you've got what can be called a shelf life for your collagen. It is going to break down over time, and it does this naturally the moment that there isn't something maintaining that biomolecule, okay? So your biomolecules are being repaired, they're being created, they're being held together in your body. Once you've died, you've got no control over your protein, particularly over the amino acids that make that protein up, and all of this stuff begins to break down and decay. And so 500 years is your sort of standard half-life for collagen as a complete unit. But a new study, it says, from MIT offers an explanation for how collagen can survive for so much longer than expected. Okay, well, let's have a look at what this report from MIT is. And we've got it just up here. It's quite a complicated paper, as you can see. There we are. There's your picture of your dinosaur with your stuff in it. And look, there's quite a lot of equations, right? You notice all of these, you've got bentide rings and all sorts in here, like lots of diagrams, lots of equations. It's a big thing for people who like mathematics, which is great. But let's just have a look at the breakdown of effectively their argument, which is why these reports, these little sort of science reports, are actually quite useful, because they do break it down into simpler terms. So let's go back here and have a read down. The research team, we're starting here, look, the research team has found a special atomic level interaction that defends collagen from attack by water molecules. Now, there's lots of outside features that can not just, I mean, you're naturally breaking down all the time the moment that you're dead, but there's lots of outside features that can accelerate that decay, help to break it down even quicker. And one of those is hydrolysis, right? Basically water molecules breaking your peptide bonds down. We provide evidence, they say, we're starting here, we provide evidence that interaction prevents water from attacking the peptide bonds and cleaving them. This flies in the face of what happens with normal peptide bonds, which has a half-life of only 500 years. Okay, collagen is the most abundant protein in animals. There's your little comment there. Collagen is the scaffold that holds us together. What makes collagen protein so stable and such a good choice for this scaffold is that, unlike most proteins, it's fibrous. Now, that's certainly a true statement. It's a long, stringy, fibrous protein, but it is still a protein. Okay, it still breaks down over time. Okay, and in the past decades, paleobiologists have found evidence of collagen preserved in dinosaur fossils, including an 80 million year old Tyrannosaurus rex and a sauropodomorph fossil, a sauropod long-necked dinosaur that is nearly 200 million years old. And we've now found it in crocodilian stuff that is over 200 million years old. And by the way, this isn't the odd thing going on here. There have now been over 150 papers detailing collagen in original biomolecules in ancient bone. There's been over 200 papers that discuss just the presence of soft tissue, original biomolecules in fossil bone. And I think it's also important to point out, before I get down to comments and stuff, is that there's a clash of terminology here as well. You see, when we say soft tissue, what most people are referring to is the presence of original biomolecules. But soft tissue can also mean soft, squidgy stuff that's preserved, right? So when you find a fossil jellyfish, for instance, you've got preserved soft tissue, right? Because jellyfish are all soft tissue, right? But you haven't got any of that soft tissue, original soft tissue, actually remaining in the fossil jellyfish, right? You're dealing with an impression or so on and so forth. Excellent evidence for rapid burial, but not original biomolecules. When we're talking about soft tissue in this context, in the dinosaur bone context, we are talking about the original biomolecule. We're not talking about skin impressions or lung impressions or all this kind of stuff that we find. We're actually talking about original biomolecules from the original dinosaur that have been preserved within, trapped within the bone. And so when you get the bone and you take your sample and you basically demineralize it and then digest the bone using an acid. One technique we use is trypsin digestion. You're removing the minerals that have permineralized the bone. You're breaking the bone down, digesting it, and you're left with a little solution. And if there's any original biomolecules in that bone, they will now be in that solution. And that's what you can then go on to test. So effectively, the crux of what they're trying to claim is that the lack of water, as well as the fibrous structure of the collagen, of the protein, means that collagen could last for millions of years. Now, there's two issues before I bring Diane in. First of all, the world expert in collagen, ancient collagen and collagen decay, is a guy called Buckley from Manchester University. He's pretty much the authority on this issue from a ancient collagen perspective, right, a paleo collagen perspective. And he says that, and this is a quote from him, there is less than 1% chance of less than 1% protein remaining in less than 1 million years. Now, the lessers are there to cover his back, but effectively what he's saying is even under an optimal burial environment, and he does use that phrase, even under an optimal burial environment, which is the perfect conditions on the perfect permineralized dinosaur bone under steady conditions, which, by the way, you don't find in the real world. You get a lot of fluctuation of conditions in the wilds of wherever. Even under optimal burial conditions, you have 1 million years maximum before you should have no detectable collagen whatsoever. Now, this is coming from a paleo, biologistics perspective, a paleochemist perspective. If you speak to the likes of Ed Neeland, who's done stuff with creation research in the past and is associated with us, his background is basically biochemistry. He makes these things for a living. And the remarkable thing is that even though a million years is nothing compared to the 200 million years that we're dealing with some of these bones, the reality is when it comes to collagen is that it's even more fragile than that. It will break down extremely quickly. We've already seen the half-life is somewhere between 450 and 500 million years, even in a good condition, right? So your chances of getting collagen surviving for 200 million years is an absurd concept just on the face of it. And as Ed Neeland have said, it's effectively like trying to ask a glass of milk to stay fresh in the sun for 40 years, right? It flies in the face of all of our scientific knowledge and all of our logical understanding. But Diane, perhaps you'd like to comment as a biomedical background, about collagen inside dinosaur bones, because it really seems like they're sort of, grasping at straws here to try and turn something which is inherently fragile, even the most stable of the proteins is still inherently fragile, and they're trying to explain this away by the lack of water and the like, to be able to last for 200 plus million years.
Well, you can't keep water molecules out of anything in the real world. And that's what's important. It's all very well to do something like this in laboratory conditions. But out in the real world, there are water molecules everywhere. And I once heard someone describe water molecules as being brutal because they're constantly moving and they do break things down. So we think of bones as being, as dry as a bone. Well, there's nothing dry about bones whatsoever. And there's certainly nothing dry about bones that are still inside the body. So if a dinosaur gets buried, that is a very watery environment. And even if it dies in the desert and gets desiccated, there are still millions of gazillions of water molecules in sort of every microscopic volume you care to. Now, bones are not dry. They're full of organic matter. They're full of living cells, and they have tissue fluid flowing through them. So that's going to be there when a dinosaur is buried. how do they explain where all the water molecules went to? And you've got to look at things out in the real world. And biology is soft, squashy, watery sort of stuff. And there's no such thing as dry as a bone. They're very wet.
There's also no such thing as, I was going to say, there's also no such thing as dry soil. There's always water molecules because it's part of the structure of the minerals.
Yes.
And even all of these experiments, they are being done in an extremely controlled laboratory situation. Right? It has to be, because you need to have things that are repeatable and testable. The problem then is trying to translate a result from something in a controlled lab environment into something that is out in the real world. Okay. So even if you can show that you could make some collagen last for 1 million years, which, by the way, has never been done, right? Or even if you could show that it could last for 10 million years, which has never been done, and I don't think ever will be done, you still haven't got an immediate translation into, therefore, we have an explanation for soft tissue in dinosaurs, okay? Because you have got so many outside contributing factors for what should be causing collagen to decay very quickly. In fact, you can measure the decay in biomolecules. You can actually, artificially age these under conditions that are similar to the real world, and they just fall apart. So,
Joe, can I just interrupt you a moment? Because I notice we have some new viewers who don't know you. Welcome, James and others. But you're sprouting on as if you know a little bit about this. So would you tell people what you're doing your study in terms of dinosaur bones, so they've got an idea of what your background is?
Sure, absolutely. Let me just pull up a little graphic for you. It'll just take just a moment. So my first background was in geology, specifically in paleobiology. So really looking at the study of living things in the fossil record, if you like, which is more about paleoecology, right? Mixed environments and so on and so forth. I also worked as a zookeeper for a little while, but in recent years, I've been doing most of my work with soft tissue inside dinosaur bones, particularly ancient biomolecules, right, and analyzing. So we take bones, we take particularly dinosaur bones, and we've really got ourselves a little bit of a sequence, okay? So we've started with a mammal bone, a Paleotherum bone, which is supposedly 33 million years old. We've gone back to things like iguanodon bones at 130 million years old. We've gone back to Jurassic Edmontosaurus rib bones, which are supposedly 150, 160 million years old. We've gone back to crocodilian bones that's supposedly over 200 million years old. Okay, so a nice wide range of this, so-called soft tissue. What we do is we start off by taking a sample. You have to grind your sample pretty fine in order to be able to get it broken down enough, digest the bone, and then you end up with a test using a mass spectrometer. Now, I'm just going to share my screen here in order to give you a little bit more of an idea about what we're looking at, okay, in terms of explanation. Here we go. And we're going to try and break the science down to as simple as we can. So hopefully you can see that on the screen now. Can you see that up on the screen? Yeah, good. Okay, now you're not going to be able to read all of the words because they're tiny. This is a proper academic poster, okay? This is something that we present in a secular research conference, basically detailing results, okay? Now, you might just be able to see the picture in the middle of the jawbone that we tested. So this is a Paleotherum jawbone. It's a mammal jawbone, sort of like a small sort of tapir type thing, right? Which supposedly is 33 million years old. Now, remember the comments of Buckley. Any kind of soft tissue, particularly collagen, should be non-existent in anything over 1 million years, given our current understanding of the science behind the decay of soft squidgy stuff inside dinosaur bones. Now, this is a poster detailing some of the results that we found, and it was found using a technique called mass spectrometry. Okay, mass spectrometry in a nutshell. There's your periodic table of elements, right? You remember it from high school, okay? And you've got your periodic table of elements with all your different elements in it, and you'll remember that there are numbers, okay? Numbers all the way up to where are we, 120 or something now. I think we're on 118 on there. Okay, so this is called the atomic number. Now, the atomic number gives you a detail of how much mass there is inside this particular atom, right? The more mass there is, the higher the atomic number. Now, if you look at number 1, right up in the top left-hand corner, you'll find that it's hydrogen. Okay, and you should know something about hydrogen. It's extremely abundant in the universe and it's extremely light. And this is for good reason. You see, normally an atom is made up of 3 parts, a proton, a neutron, and an electron. Hydrogen is only made up of 2 parts. Number 2 is helium. You know that helium is light because you fill your balloons with it, right? All the way up to the big one on the middle as an example, right, is iron, which has an atomic number of 26. In other words, you've got lots of different masses, lots of different, think of it as weights, okay? Well, what is a mass spectrometer? Well, there's me working on a mass spectrometer in the lab. There's one of our colleagues trying to work out which tube goes in which bottle. And in particular, this is known as a LCMS, that's liquid chromatography mass spectrometry. Now, what we do is we get our dinosaur bone, we've got our sample, we've digested it and demineralized it, we are left with a solution. And in that solution, if there's anything that's organic in the bone, it'll be left in that solution. We then run it through this mass spectrometer. And inside the mass spectrometer, there is a column. Now, the column is a very, very thin but very, very long coil, okay? It can be several meters long, in many cases, sometimes tens of meters long, okay? Really, really long coil, but very, very thin. And you take the solution and you blast it through the column. Now, remember that, table of elements, right? Really light all the way to the really heavy elements based on their mass, which is based on their atomic number. So anything light is going to whiz around the column really, really, really fast and reach the receptor first. And then the heavier items and the more complex molecules are going to go around slightly slower and reach the receptor slightly later. Okay, what are the results that we find? Lots and lots of squiggly lines on a nice graph, and most people probably won't be able to interpret that. So let's break it down. Okay, can you see on the bottom you've got 1085 and 1086, right, on both the green squiggly lines as well as the red squiggly lines. Now, this is what we call the mass range. Okay, it gives you an indication of what is being found and how heavy what is being found is. Now, we won't go into some of the complex science, but I just want you to notice one thing, okay? The red one on the bottom is modern day turkey bone. Now, turkey bone is going to be full of collagen because it's a bone and it's fresh and it's modern. It was from Christmas dinner, right? And so we test the turkey bone because we know that it's going to be full of collagen. It's what we call our control. And so we look in the mass range of 1085 to 1086, which is where collagen should be if it's found, and you can see all the lots of little squiggly lines. Now, the little peaks, we call them, the squiggly lines up, is an indication that something has been found. Now, in the general rule in mass spectrometry, if you find 4 or more peaks, you've got good, strong evidence that what is you suspect is there actually is there, okay? So we can simply, let me get my little pointer up here so we can show you. There we go. We can count 1, 2, 3, 4, 5, 6, little one there, 7, couple of little ones there, 8, and 9. So we've got very good, strong evidence, okay, because we've got way more than 4, that there's lots and lots of collagen in this turkey bone, which is what we would expect because it's a fresh bone. Okay, well, let's go to our Paleotherum jawbone. You see here, PLM jaw 2. This is the green one, and let's see, 1, 2, 3, 4, 5, couple of little ones, 6, 7. Okay. So we've also got good evidence that there is collagen inside the Paleotherum jawbone. But not just that. Once you've actually scaled the two together, notice the correlation. Peak here, little bump of a peak there, but a peak there and a peak there. Peak there and a peak there. Big old peak there, just like the turkey bone. Little one there, little one there, one there. So in other words, not only are there lots of peaks in the collagen spectrum for the Paleotherum jawbone, but they pretty much match the peaks that are found in the turkey bone as well. And the peaks are in roughly the same ratio and pretty much at the same timestamp. So remember, you've got your big long coil and your stuff whirling through it. And so you should find collagen at about the same time, no matter what sample you test, particularly if you test on the same day. So the point is now the great thing about this, right, is if you just take, a thin section of your bone and stick it under a microscope, you get lots of pretty pictures of what appears to be soft, squidgy stuff. And I suspect that it is. I'm pretty convinced of that. But all pictures are open to interpretation. The nice thing about this is that there's very little open to interpretation about it, because you're just dealing with a string of numbers. You're actually examining and you're actually testing what is physically inside the bone, and you're getting a big long string of numbers which you can actually compare one to the other. So this is a really nice example of good, strong evidence that you're finding collagen inside this sample. Now, I'd like to go one step further, okay, and just finish off by making the rather important point that the big question about all this research is, what about contamination? How do you know that I haven't spat in it or dropped some, skin in it, or so on and so forth? Okay, well, remember I mentioned that crocodilian bone we tested, over 200 million years old? Well, the nice thing is that even evolutionary speaking, crocodiles have remained crocodiles for over 200 million years. Now, that's some good evidence of living fossils against evolution. But it also is handy for us, because what we did is we took that crocodile bone, we not only tested it using mass spectrometry, right, and several other techniques, we actually did proteomic analysis. In other words, sequencing the protein that we found inside the bone, that protein being collagen. Now, we can take that sequence, we can run it through a database and see if there's any matches. In other words, can it match any real world collagen that we still have today? And this 200 supposedly million-year-old crocodile bone matched not only the Nile crocodile, but also the saltwater crocodile and the Chinese crocodile. In other words, you have very good, strong evidence of the endogeneity, the fact that this soft tissue is actually from that bone. It's not contamination, and it is impossible to be millions of years old, given our current knowledge in science. Hopefully that makes a bit of sense.
Thank you for that. I'm just going to make two comments because we're running out of time here. I think you've just given us a way to tell whether the butcher shop has really put the right use-by date on our turkey bones. If we can afford to do all those fancy tests for collagen, that would be great. But I noticed James is having a few interesting questions there. So, James, welcome to the program. Great to have you on board. And you've asked a question that deals with, is this a Catholic thing to believe in young earth, or is it a Protestant thing? One of the posters Joe showed at his recent conference is, it's not religion versus science, but truth versus error. It's a statement I've found very, very helpful, because when you and I stand, and I've said this to many professional scientists in debates and that, when we stand before the final judge, Jesus is not going to ask us, now, did you or did you not believe the Archbishop of Canterbury? I'm really mad about this sort of thing. Or did you believe the Pope or not? He's going to say, did you believe me? So can I encourage you, pick up a Bible, see what it says from Genesis to Exodus to Leviticus, right up to Revelation. That's where I started. I don't come from a church background. I do go to church now and worship Christ as Savior and Lord, but not the leader of the church. He's just a helper who's there to help me to know more about the Lord Jesus. So pick up your Bible, find out what it's got in there, and then come back. And as Neil and the others have graciously helped you, use a capital Q. We really do love having new visitors, and we'll try and do our best to assist you. Joe, back to you for any thank yous.
Yeah, and just a reminder that, we normally have a fairly extensive Q&A session, but we've gone on for a little bit. And in fact, there's still even a part 2 of Glenn's report, which we'll have to come back to next week. So keep an eye out as well for a few polls and stuff that will come out about the future of creation conversations, but we'll come back next week, I think, probably with Glenn's program, part 2, and we'll try and deal with some more Q&A. And a reminder that if you do ask a question but we don't get to answer it, or don't get to answer it fully, we do save your question. So thank you, James. We'll hang on to your question, because what we do every roughly every 5 to 6 weeks, what we do is do a Q&A special. So we dedicate an entire program, hour and a half, just to Q&A, dealing with your questions from previous weeks, as well as anything else that comes up live while we do the program. That always turns out to be a very popular program as well. I don't think there are any other thank yous from what I can see. Apologies if I've missed anything, but I think it was just the two tonight. But thank you very much for those who support us. Continue to share and like and subscribe and so on and so forth. And we will see you next week. Any last words from anybody? No?
Good.
All right. We will see you next week, folks. Goodbye and God bless. And we will see
You'll
you
see
soon.
this next week.
We'll see the big footprint.
Wow.
All right. Catch you later, folks.